Hi, geometry students, and welcome to 2.2. And we are going to be doing something very similar as to what we did in 2.1. But this time, instead of just working with lines, we're working with angles. So if you would move or would get out your textbook and turn to page 61, we're going to be taking a look at angle bisectors. And if you look at the very top, there's a definition. It says an angle bisector is a ray that divides an angle into two angles that are congruent. In the photograph of the hang glider, BD bisects ABC. So angle ABC, because it divides the angle into two congruent angles. Before we move on, I actually want to go over some vocabulary with you and some symbols to make sure you understand what they are. So if you see this, and I think we may have done that in class, and in this case it was angle ABC. If you see this, that is just the symbol for angle. So make sure that you know that. And as we move through, you'll see other symbols. If you look at example number 1, underneath the word solution, there's a little m. And that represents measure. So make sure that you take note of these things either in your brain or on paper. Because if you don't know what all of the different little symbols or letters mean, then you could get lost. So we see on that hang glider the angle ABC. It looks to be an obtuse angle, and hopefully you remember what that is. It looks to be pretty wide and more than a right angle. Now we find out that there's something bisecting it, and that's called an angle bisector. And it looks like the central part of the hang glider cuts right through it. And that would make the angles on both sides congruent or equal. So I want to take a look at example number 1. And I'm going to put that on the board. And what we have here is an obtuse angle. And remember my love of straight lines, and make sure that your lines are straight when you do homework. Now we have a line cutting through, and mine might not be exact. But let's just check. Yes, these are like that. All right, our angle is going to be, remember how we name our angles? We name them with letters. Oh, and I forgot this one. So it is going to be A, B, C. Now, if I start here, that means I'm working like that. I could also call it CBA. You can do either one there. All right. So we know that this is a bisector, and we know that the measure, and so that's how I measure this, how I indicate that it is a measure. This is 110 degrees. Now, what I find out, or this whole thing, I'm sorry, I'm looking at this wrong. This whole thing, and that's what this means. If I just want to measure this one, I'm just going to do that half of the little semicircle. This whole thing is 110 degrees. So ABC equals 110. Now, what they want to find out is what do each one of these individually measure. And because we know that this is an angle bisector that is cutting straight through, we know that they are going to be congruent. So I would put, I don't know that they put the little symbol in there, but I'll put the little symbol that indicates they are congruent. Now, that means that this side is going to be 55, and this side is going to be 55, because the whole thing equals 110. Might be a little easier to write it like that, because that indicates that the whole thing is 110. But then each one of them are going to be 55, because they're each half of that whole. Now what I want you to do is hit pause, and I want you to look at checkpoints 1, 2, and 3. They give you the whole measurements. Actually, I want you to look at 1 and 3. We're going to come back, and then we're going to look at 2 together. So they either give you part of the measurement or they give you the whole measurement. Make sure that you look at your the little arcs. And if you have a little arc that goes like this, it's the whole thing. However, if you have a little arc that looks more like this, it looks like a little M, sort of. It's got a little section that comes down there, and I will tell you that H is like that. It's going to be a different, it's not the whole measurement, it's only half. Anyway, hit pause, try them, and then when you have finished them, come back on and we'll do number 2 together. So if you're back, I assume that you did take a look at the measurements. Now in number 1, 52 degrees represents just that one side. It represents JHK. Doesn't represent the whole big triangle, because we see 2 littles that kind of look like a little M in there. Now that one is going to be, well, nope, I'm wrong. Actually, it is representing the whole thing. It's so hard to tell on these sometimes, and it looked like that. So if you indicated that 52 was the measurement of the whole thing, it should be 26 degrees for each one. JHK and KHG would each be 26. Now, if you looked at it as just the measurement for the one, then the other side would also be 52. I'm sorry if that's confusing. And then number 3, 161 is the measurement for the whole thing. So that gets divided into half, and it's going to be 80.5. Now, for number 2, what you needed to do, there's a step. Geometry is all about steps. And it's all about putting pieces of your index cards together. I'll give you that little clue. So what we want to do is we want to do some steps here. And I want to show you another symbol. Whoops, let me get my line there. I want you to learn another symbol if you haven't already. We do have a bisector in here. We know that the bisector divides it clean in half, so that the same measurement on each side. Now, what got added into this is this symbol. And if you didn't, it looks like a baseball diamond. And if you didn't know what that was, you'd be totally clueless. This symbol represents a right triangle of 90 degrees. And so if you see this stuck in an angle, here would be a better. If you see that in your angle or in a triangle, you know that's 90 degrees. So you need to make note in your notes or in your head that you know anything like this. It doesn't matter how it is drawn. This one is straight up and down and over. But we know this is 90 degrees. So we know that the whole measurement is 90 degrees for this whole thing. Therefore, we know then that each individual angle is 45. So make sure you know this symbol that indicates the 90 degrees in an angle. All right, let's take a look at the next page. And we're basically doing the same things that we did in 2.1. Now they are showing us one side of the angle and we have to figure out the other side. So if you look at example number 2, it tells us that angle LMN, MP is the angle bisector that cuts through LMN and LMP. And it tells me that LMP equals 46 degrees. Now I know about bisectors, and I know if it cuts straight through, then that means that both angles are congruent. So if LMP is 46 degrees, that means that PMN is also going to be 46 degrees because they're equal. And then if I needed to know the measure of the whole thing, I would add them together and come up with 92. So it's kind of working a little bit backwards on that. Let's stop, do a pause, and I want you to do the checkpoints, and then we're going to do another one of those algebra things that we saw before. So stop, do the checkpoints, and then come back, and I will go over those answers. All right, so the checkpoints. We have RQS and SQP. Those are congruent angles. We know that one of them is 29 degrees, so that's going to make the other one 29 degrees. And together they will be 58 degrees. Now it also asked for whether it was an acute, right, obtuse, or straight. And in this case, it's acute. Remember, acute is less than 90 degrees. Number 5, we know that RQS is 45 degrees. That makes SQP also 45 degrees, and together they are 90, making it a right angle. Finally, the last one, PQS, or we don't know the measure of that. SQR, though, is 60 degrees. That's going to make PQS also 60 degrees. Together they'll be 120, and they are an obtuse, that is an obtuse angle when they're put together. Okay, finally, over in example number 4, we have some of that algebra thrown in again. And what it wants us to do, it says to, it tells me that RQ bisects PRS. And it wants me to find the value of x. Now, since I know that it is a bisector, I know that 6x plus 1 is then going to be equal to 85. So let me put that up on the board. 6x plus 1 equals 85. If you're lost, you need to go to page 63. We're looking right in the middle of the book at example number 4. It's giving us an algebra problem, and we know that the 6x plus 1, the degrees on the one side, is going to be equal to the 85 because there's an angle bisector. Now, let's reach far back into our algebra from last year. We're going to subtract 1 here, subtract 1 here, because we want to get x all by itself. Whoops, I need to subtract and get just a 4 there. I still don't have x all by itself, so I have to divide and divide, and then I'm going to be left with, what is 84? I don't have my quick brain on today. 14. X equals 14. So sometimes they'll throw in these little problems. You just need to remember that whatever is on both sides of that angle bisector is going to be equal. I'd like for you to hit pause and try the 2 checkpoints, 9 and 10. Come back, I'll give you the answers, and then we will be finished with this lesson. So if you're back, I'm assuming that you did 9 and 10. And for number 9, we'll have x plus 12 equals 55. And the x will come out to be 43. And number 10, you'll have 8x plus 3 equals 9x. And in that case, the x will come out to equal 3. So just as with any other videos, if you're confused by anything I've taught, if you are confused by any of the homework, please write those questions down, maybe even make a page in your notebook that says questions for Mrs. Jernigan. Write them down, and then we will take care of them when we get back to class the next Wednesday. So I hope you have a lovely day, and we will see you for the next video.